Hi, everyone. Welcome back to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower costs, and provide you with best practice and design considerations. I'm your host today. My name is Clint Wyckoff, and I'm an enterprise support manager based out of Pittsburgh, Pennsylvania. Again, thanks for taking a few minutes to join us today on the Twitch stream. Joining me today from AWS Enterprise Support are TAM colleagues of mine, Hiren and Mardianto. So Hiren, let's start with you. Why don't you give us a quick introduction and welcome to the show.
Hello everyone, I am Hiren Purabia. I am a technical account manager based out of the New York office of Amazon. My pronouns are he and him. Nice to meet you all.
Hi everyone, my name is Mardianto Hadiputro and I'm a senior technical account manager at AWS based out of New York City.
Fantastic, and welcome to the show, Hiren and Mardianto. Like I said, thanks for taking a few minutes to join us today. The topic for today's conversation is going to be infrastructure as code with AWS CloudFormation, getting started with infrastructure as code in AWS CloudFormation. We're going to specifically focus on how to get started, writing some simple CloudFormation templates, and then we'll go ahead and deploy those for you here on the show. Before we get to the topic and conversation at hand, just a quick note to the attendees online, please. Please feel free to utilize the chat there on the right-hand side of the Twitch screen. We're interested in where you're joining us from today, but then we also want to hear, are you utilizing infrastructure as code? Are you leveraging CloudFormation maybe today inside of your environment? What pipeline is it a part of? What applications are you deploying? What use cases are you looking after? And then if you have any questions along the way, throw those in the chat as well. We're interested in your feedback, so we'll drop a link in the chat here in a second to a survey that we have online, so that it'll give you the opportunity to give us feedback about the show, AWS Supports You, what you like, what you don't like, maybe what you want to see in a future episode. But yeah, so with all that out of the way, I'm going to throw it over to Mardianto first, and he's going to give us a quick rundown of today's episode.
Okay, thank you, Clint. So before we begin, I'll just start with the AWS Support You. So at AWS, customer obsession is our #1 leadership principles. We start from the customer and we work backwards. And as a technical account manager at AWS, I am the customer's advocate. I listen to my customers' need and help them in various capacities. So for example, I provided workshops to my customers so that they can have hands-on experience with AWS services, ranging from basic, intermediate, and advanced level. I also provide best practice guidance on AWS services throughout our regular meetings. And I also manage my customer support cases and escalate them to the right service team if necessary. And also constantly keep my customer up to date with the latest product features and upcoming launches of AWS services. And if there are any specific AWS services that my customer would like to know deeper, I work also with AWS subject matter experts to help the customer deep dive into the service. And whenever there are any features that my customer would like to see it being implemented in any AWS services, or for example, CloudFormation in this case, I will submit a product feature request on their behalf to the product team. And these are just a few examples of the many enterprise support entitlements that TAM provides. And my colleague here, Hiren, will provide more specific cases to AWS CloudFormation.
All right, thank you, Mardianto. So yeah, as a technical account manager, I remember how I helped one of my customers with AWS CloudFormation. So my customer approached the enterprise support team with an interest of deploying infrastructure in AWS across multiple accounts and regions. So I recommended them to use AWS CloudFormation and take the infrastructure as code path. They restricted access of their developers to build infrastructure in the AWS through Management Console and only allowed them to deploy infrastructure through their CI/CD pipelines. And this helped them quickly scale their infrastructure in AWS while also building the infrastructure in a more secure and reliable manner. So that was one of the ways that technical account managers help our customers in deploying CloudFormation. So now let's go to the next slide and let's see at today's agenda. So today we will cover the fundamentals of infrastructure as code. We will introduce the AWS CloudFormation service, and then we'll look into some of the fundamental level features of CloudFormation along with a demo on how to configure and deploy a CloudFormation template. Throughout the session, we will answer your questions that come up in the chat. In this session, we are only focusing on the fundamental features of CloudFormation, so we won't be covering any advanced features, but we will look at them at a higher level. So with that said, let's first dive into what is infrastructure as code. All right. So infrastructure as code means that instead of building and deploying the infrastructure manually, we write a code and we give instructions and details on the infrastructure that you want to create. So we are codifying the infrastructure. Now you may use various code editors to achieve this. Once the code is written, we check it into a version control system and then review the code files with our team members. And once it is ready, we deploy it into our various environments. By doing so, we get several benefits over manually deploying infrastructure. So let's look at those benefits. So this code acts as a single source of truth to deploy the whole stack. If anyone wants to go back and see what infrastructure configuration got deployed, they can check out this single source of truth. It allows us to replicate, redeploy, and repurpose the infrastructure. So what does this mean? This means that we can replicate the same infrastructure configuration across multiple accounts and regions. We can also make minor changes and repurpose the infrastructure code as needed before deploying it in another environment. This allows us in quick deployment of infrastructure across multiple regions and accounts, thus saving a lot of time of the development teams, and they can use the time for other higher priority objectives. Since you are deploying your infrastructure as code, you can save the infrastructure code along with application code in a version controlled manner. And anytime you want to go back to previously deployed infrastructure, you may do that quickly. Another important benefit of infrastructure as code is that it is transactional in nature. So what this means is while deploying the infrastructure, if there are any issues, it rolls back the deployment to the last good state. Now, since we have codified our infrastructure, we can now deploy it through our CI/CD pipeline and automate this deployment along with the deployment of our application code. So now let's look at two infrastructure as code solutions offered by AWS at a higher level, and then we will dive deeper into AWS CloudFormation. All right. So AWS has two infrastructure as code solutions available, AWS CloudFormation and AWS Cloud Development Kit, also known as CDK. So let's look at some of the features of each one of them. So using CloudFormation, one can model, provision, and manage AWS and third-party resources by codifying the infrastructure. So CloudFormation enables management of third-party resources by using the AWS CloudFormation registry and AWS CloudFormation custom resources. Now, these features are advanced, so we won't be covering it in today's session, but we will share links to those features if someone wants to learn more about them. Now, one can create, update, or delete CloudFormation stacks across multiple accounts and regions using something known as stack sets. This is also an advanced feature, so we won't dive deeper into it, but we will share documentation for it in the chat if anyone wants to look into it further. Now, AWS CloudFormation has a GUI option available without any additional cost. And CloudFormation manages the state of the code files for the end user. So the end user can focus on the code deployment while CloudFormation takes care of the management of the code files. And CloudFormation uses two configuration languages. One is JSON and one is YAML. Now let's look at AWS Cloud Development Kit or CDK. This is an open source software development framework. There is a GitHub available for it, and you can view various contributors there. CDK provides various benefits, so let's look at them. Firstly, it makes it easier to onboard to cloud. Your team can leverage the existing skills and tools to code the infrastructure in cloud. Also, there are several high-level components available which pre-configure cloud resources, which you can leverage and thus help in accelerating your onboarding to AWS Cloud. It is customizable and shareable, so you can design and build your own reusable components which meet your organization's security, compliance, and government requirements. And you can share it and reuse it across different business units within your organization, thus reducing your time to production. It aids in faster development process. So you can use familiar programming languages and features such as objects, loops, and conditions. And using them, you can build your cloud infrastructure from your own IDE environment and leverage your existing testing frameworks. Now, since you are building your cloud infrastructure from your own existing IDE, there is no context switching. So you can use the same programming languages to write both the cloud infrastructure code and also the application runtime code. And you can visualize the CDK application stacks and resources with something known as AWS Toolkit for VS Code. So which programming languages can you use in AWS CDK? Well, currently the generally available languages are JavaScript, TypeScript, Python, Java, and C#, and Go language is available in developer preview. Now we will not dive deeper into AWS CDK, but we will share documentation around it for you to explore further. So these are the two infrastructure as code solutions offered by AWS. Before we dive deeper into AWS CloudFormation, let's see if we have any questions in the chat that we can answer.
Thanks, Hiran. So there wasn't necessarily a direct question. There was a call out that came out a few minutes ago by, what was their name? Dare Felix _ FFM calling out, the difference between CloudFormation and CDK. CDK under the covers actually creates CloudFormation templates, and then they just called out that they really like it, and they said that CDK is quote unquote really amazing. Thanks for the feedback there. And then they also asked questions specific to like Terraform, and really the focus of today's conversation is around CloudFormation and the CDK and infrastructure as code native platforms within AWS. Terraform is definitely an option. Whenever I was at TAM, I supported many customers that utilize Terraform. So really it's up to you from an application team or an organization to sort of pick which platform best fits your use case. So sort of just the focus of today is going to be around CDK and CloudFormation. And see here, if they say they recommend using the CDK with TypeScript and JavaScript. So that's good feedback there. And I'll throw a link here in a second in the chat that points you to any CDK specific documentation, getting started, that type of stuff. Here in Mordianto, any call outs or anything there that you wanted to make before we continue along?
Yeah,
yeah.
Go ahead.
Go ahead.
Yeah, I was just saying, thank you for sharing the feedback that you are liking CDK, and a good call out of which languages are convenient. So that's a great feedback, and we'll keep that in mind. Thank you.
Just to add a little bit, so I think we had good comments. Like CDK is mostly good if you're a software developers, since you are familiar with programming languages. But so for some people who are not familiar with like programming languages, CloudFormation is still, I think, the first step as well. Like when you get started, it's still a good way to do. And again, CDK is also using actually CloudFormation to deploy the AWS infrastructures.
Mm-hmm. I think the important takeaway for folks, and at least the customers that I've worked with that have implemented any infrastructure as code, is understanding that it's stateful, so you can detect drift. So if somebody goes in and changes an instance size or an environment gets deleted, it can be easily redeployed. I've seen customers also utilize infrastructure as code as a variation of a DR plan. So maybe you want to redeploy an application in another AWS region. That's another really good use case for infrastructure as code, and CloudFormation is just one variation of that. So with that, I think, Hiran, why don't you continue to present to us today?
Yeah, thank you, Clint. All right, so let's dive deeper into what is AWS CloudFormation. So as we saw in the previous slide, AWS CloudFormation is one of the infrastructure as code solution offered by AWS. It can be easily integrated with other AWS services, And when AWS releases new services, AWS CloudFormation has quick integration for those new services as well. Now, CloudFormation is a simplified way of creating and managing collection of AWS resources by codifying the instructions and details in a text file, and you can use JSON or YAML language. And then this template becomes the single source of truth for your infrastructure. So by doing so, it helps you standardize your infrastructure components used across your organization, thus enabling configuration compliance and faster troubleshooting. So what does this mean? What this means is that if any of the infrastructure configuration is changed or deleted, which may then violate compliance of the infrastructure, then in that scenario, by using AWS CloudFormation, we can either disable the changing of the configuration or we can revert back to the original configuration. Now it enables orderly and predictable provisioning and updating of resources. So while deploying the resources, sometimes it may happen that some resources have a dependency on other resources. AWS CloudFormation helps provision the resources in an orderly and safe manner. And if there are any issues or errors while deploying the infrastructure, it will roll back to the previous good version. And this rolling back to previous good version is possible because we can enable version control on our AWS infrastructure. Now, CloudFormation has strong integration with AWS IAM service. So this allows for management of CRUDL permissions for resources, which are create, read, update, delete, and list permissions. Now, CloudFormation has a feature called hooks, which can help enable scanning of your CloudFormation templates for security and compliance issues. Also, CloudFormation guard rules can be used as policy as code rules that you can validate your JSON or YAML formatted data. Now, these are also some of the advanced features of CloudFormation, so we'll not discuss them in today, but we will share documentation around it for those who are interested in them. Now, you may deploy and update the CloudFormation stack either through AWS Management Console or through command line or through AWS APIs. And CloudFormation service does not charge the customer. You only pay for the resources that you create by using AWS CloudFormation. So at a high level, let's look at the steps needed to build and create a CloudFormation template. All right. So firstly, the deployment team writes the code which has the instructions and details about the infrastructure that they want to build. And then they save these code files either locally or on a S3 bucket. Then they can use the CloudFormation service and they can either upload the locally stored code files or they can provide the URL of the S3 bucket where they store the code files. At this point, AWS CloudFormation essentially works as an API wrapper. So AWS CloudFormation calls the APIs that you defined in your CloudFormation template, and it passes them as API calls to those services. And these APIs are called in parallel, and CloudFormation manages any dependencies or relationships between the different resources that are being created. And once again, you only pay for the resources you use. Also, CloudFormation has good integration with other open source tools like Ansible, Puppet, Chef. So if you are using those tools already, you may integrate CloudFormation with that. Let's see if we have any additional questions that have come up in the chat before I hand it over to Madhyanta.
No, there hasn't been any additional questions from the audience, but I do have a question for you here. And are you a JSON or YAML type of person?
I personally prefer JSON, but I don't have a strong preference. I'm good with YAML as well, but if I have a choice to pick, I'll pick JSON.
Okay, and then the second question I'll ask you there here, and maybe a tip for the folks online, which editor, which IDE is your IDE of choice?
Yeah, so personally, I use the Visual Studio Code, but I have used other IDEs as well, like there is Atom also available.
Mm-hmm.
Yeah, no, again, no preference, just whichever one works well for me.
Sure. How about you, Mardianto?
For JSON YAML, I prefer YAML because YAML, I can put comments into that. Although right now, the newest JSON, they can put kind of, they have to work around to put comments. I still prefer YAML. For configuration, I think that's the way to go. And for text editor, I just use Sublime in my MacBook. Yeah, I'll keep it simple.
Gotcha. So while we were having the conversation there, one question did come in here. What CloudFormation tools can you recommend for popular IDEs like IntelliJ or VS Code? Anything to offer there?
Yeah, one thing I've seen is for, I think, VS Code, there is a lint option available which can help you review the code and show if there are any errors.
Mm-hmm.
But feel free to add anything, Madhyanta.
Yeah, I believe there's a tool. I don't really use that Visual Studio Code that much, but I believe there's a tool that we can share with you to make your, do the autocomplete in the Visual Studio Code for CloudFormation template.
Yeah, I will grab the link to that and I'll throw it in the chat. But that's all for now. Feel free to take it away.
Thank you.
All yours, Madhyanta.
Okay. Thank you, Hiran. So in the previous section, we have learned the benefits of infrastructure as a code in general and AWS native ISC solutions, which comprise of two services, AWS CloudFormation and Cloud Development Kit, or CDK, and also the core concept of CloudFormation. So in this section now, we will learn the structure of a CloudFormation template, how to use intrinsic functions, other parts of template, and along with the presentation, I will demonstrate writing an initial CloudFormation template from a blank document that we will improve in each demo. And the idea here is just to show you how easy it is to start codifying your infrastructure with AWS CloudFormation. So let's begin by looking at high level of CloudFormation template anatomy, or what makes a template. So what is shown here is the YAML formatted template fragments, and only the major level or top level sections are shown here for sure. And I will explain some of this. For example, the most commonly used is the parameters. So the parameters enable your user to input custom values to your template each time they create or update the stack during the runtime. And although we have this many major sections, the only required section is the resources. So this is where you actually declare the AWS resources that you want to include in the stack. For example, Amazon EC2 instance or Amazon S3 bucket. Now let's go quickly to our demo. Right, so in this demo, first I will save the file, this blank document as cfn-demo. And we'll put the extension as YAML. So in this demo, we will deploy a single EC2 instance using CloudFormation, and I will deploy it via AWS console. So I will add the template format version, which right now only has one valid value, which is the 2010 September 9. And also I will add the description here. And again, these two sections are optional, so you can just skip them. But just for practice, I like to include these two. And the only thing that is required here is the resources. So here I will add a single EC2 instance. The logical ID for that instance called web server instance. So this logical ID must be an alphanumeric, can be capital, lowercase, and 0 to 9, and it has a limit of 255 characters. So the type of this, I need to define the type of my resource. So this will be an EC2 instance. And with the properties, there are two main properties. The first is the instance type, and also the image ID, or the MI ID, which is the Amazon Machine Image. So for this example, I will grab the MI ID from our EC2 console. So first we'll click the launch instance here, and then I can get quickly the MI ID. Here, I will copy paste this MI ID here. All right. And if your company or your developer has its own custom Amazon Machine Image, this is also where you can put it your own. So now I've saved that, and let's go to CloudFormation console. So here I will create a new stack, resources, and there are two ways, as here mentioned, either in S3 URL or you can upload it. So here I will upload it from my local file. So we click next here. I need to give a stack name. Let's just put it the CloudFormation demo or CFN demo for short. And these are some of the advanced options that is not covered today. So we can skip this. And this is the summary page that also, we have nothing much here. So we just create the stack here. And this is the page where you will go to after you deploy. So here we can see the left-hand side here shows the overall status of the stack, while this part here shows the more granular events detail of your CloudFormation template deployment. So now we see the stack is complete. We have seen the EC2 instance being deployed, and I can click that on that link, and it will go to this EC2 instance that is still initializing right for now. So that's it for our demo. Okay. So let me go quickly for the metadata first before I break for a question. So first, the metadata section, it contains arbitrary JSON or YAML data, depending on the language of the template. And you can specify the objects that provide additional information about the template. For example, description for your instance. And shown here is a JSON formatted example of metadata. And if you're using the CloudFormation UI designer in AWS console to write your template, the layout, position, and relationship of each resources is captured in the metadata section. Now the parameter section. So this is an optional section also, and this is one of the most commonly used in a CloudFormation template. And they enables you that the user can pass a value to your template at runtime. That is when you create or update the stack. And you must declare parameters as one of the following: string, numbers, AWS specific types. And we use the ref intrinsic function that I will cover later to reference or to get the values of the parameter. And shown here on the right-hand side is this example of the JSON formatted template using parameter section that is asking the user to provide the S3 bucket name during stack deployment. Now let's see to our demo. Okay, so continuing from our previous template, now we will enhance it. We will add a metadata and parameter section here. So first, I will add the metadata section. So when deploying CloudFormation template via the AWS console, we can improve the experience of the user deploying the template by specifying how to order, label, or group the parameters. And this can be done with this metadata, and specifically with this key called the AWS CloudFormation interface key, which is I'm doing here. So I'm adding the label here. The default is, so in this example right now, that I'm trying to provide the user an option to choose the EC2 instance type. And this is, I'm just providing the labeling and the grouping for the parameters. So the parameter will be instance type. And I will provide the parameter labels. And I will provide the default value for that type of EC2 instance. Now I will add the parameter sections. So in here, I will add a single parameter with a logical ID of an instance type. And this type is just a string type. And I will provide the default value. In case user does not want to choose, then it has a default value. In this case, I would choose a T2 micro instance type. And I will allow user to choose from a list of values. In here, I will provide two values to the user, T2 micro and T2 nano. And I will provide the description to the user to choose one of these two instance type. And I will specify what is the default value. And also on the resources part, since we don't want to hard code the value anymore, so I will use the ref intrinsic function here to actually get the value that is chosen by user during the stack runtime. So the value, it will be, the parameter will be instance type. Now let's save this and we'll deploy it to our CloudFormation. So let me save this file. And shown here, I'm using the Sublime text editor just for simplicity. Now we go back to our previous CloudFormation and I click update here. And then I choose replace the current template. And again, I will choose the update from a local file here. So I'm using the same file. We don't need to rename it since we're just updating a stack. And we can see here, this is the effect of the metadata section, how I order and I group the parameters and the naming as well. And we can see here, there are two values, which I provided earlier, the T2 micro nano. So I will provide the T2 nano here. So we'll see the parameter will be listed here in the summary page with the value which I choose. And I can click update stack. So again, the left-hand side shows the overall progress of the stack, while the right-hand side show more granular details. And for example, this is the description of my stack, which I put there in the template. Now let's see there, and there's the refresh button that I can check. You can see this. So since I chose a different instance type here, so the previous instance will be terminated, and then CloudFormation will actually initiate a new instance. So this is something that the user needs to take consideration, especially if you have some certain updates to your EC2 instance, then you need to take that into consideration when you're deploying or updating your CloudFormation, because CloudFormation will terminate might terminate your previous EC2 instance, especially if there are some changes on the instance type. So we can see here now, the change has been deployed. So now my instance type is T2 nano. All right. So I will pause here for a while to check for any questions from the audience.
Yeah, hey, Marianto, thanks for the demo there. There was a question from Dare Felix _FFM. Are there plans to change the resource limits in CloudFormation? The number of resources per stack / nested stack is still quite limited. And I let them know I'm personally not sure the answer to that one. So what I would recommend is to go over to the repost.aws, basically the AWS online forums, and ask your question there. And you might be able to get an answer of what the team has planned coming up in the future, specific to number of resources within a CloudFormation template. I also, while Mardianto was presenting there, I threw a link out to all of the different properties that are possible for EC2, for example. So let's say you're going through and you're building, an application, or you're looking to implement infrastructure as code, and you're writing it and you're not sure of all the properties that might be available for a specific resource type within AWS. That's a good link to keep handy. That way you can see, and compare it to what you've deployed inside of maybe your dev environment, where you were going through the UI and building out your application. And as you're trying to promote it to production, you need to codify that application deployment. So that's a good link to keep handy there.
Right. Yeah. Okay. So yeah. So that's also the values. For example, right now it's limited to 200. For example, in a single template, you can deploy 200 resources. And again, if at the time here at AWS, if you would like to see that implemented, I can actually submit a product feature request to increase that number, for example, given good reasons, right? And I can advocate that to the product team. So that's a very good input. Yeah.
Yep, definitely. That is one of the benefits of having a TAM that works with you here at AWS. Yeah, we get to ask for feature requests for the product team on your behalf. Another question that just came in there: is there a CloudFormation blueprint repository?
Oh yes, there is. We can definitely share that with you through the chat.
Perfect. I will get the link to that and I will drop it there for you. I don't see any other questions, so feel free to continue along.
Thank you. All right, so let's continue with intrinsic functions. So in the last demo, we have actually used one intrinsic function, which is the ref function, which is to get EC2 instance type selected by the user during stack update. So there are multiple intrinsic functions that can be used to enhance the flexibility of a CloudFormation template, as we can see here on the slide here. And we will also share to our chat links. And in the upcoming demos, we will use the join function to join a string for naming our EC2 instance through tagging, and find a map to reference a map in the mapping section that I will cover later, and also get attribute to get a resource attribute. Now let's go quickly to our demo. So continuing from our previous latest template here, we see we have used one ref function. And I will try to modify here that I will add one more AMI ID. So I do not want to hardcode the Amazon machine image. So I will provide the user an option to actually input their own AMI ID here. So the type will be Amazon EC2 image ID. And the description, this will be the Amazon machine image. Right. And I will put the default in here. I will just copy and paste the hard-coded value in case user does not preference to use any particular Amazon machine image. And here I will use the ref function to actually get the AMI ID input by the user. And I will add a tagging. So I will name this EC2 instance through tagging. The key is the name. And here I will demo, we will use a join function to concatenate two strings together. In this case, I will concatenate using a dash. And I will concatenate basically the type of the EC2 instance chosen by the user with a string called web server. So for example, if user chooses the T2 nano, it will be t2.nano-web server. Now let me save this file and let's update our stack. Let's click update, replace current template, and upload again from local file. So this will be rather fairly quickly deployment because I do not want to change anything here. So I will just keep the instance at T2 nano. I will just keep the AMI ID as is. So when I click next, it will be fairly quickly because what it will do right now, it will just try to add a tag into this EC2 instance to give a name for this EC2 instance. Now, when I click next on the summary, we will see there are two parameters now. There are the AMI ID and its value, which I added earlier. So I click update stack here. So this will be fairly quick. So when I click refresh, should be fairly quick to complete. Now, when I go to resource again, here I'll click here on the EC2 instance ID. You can see now that this is the same instance, and we have a name now for this EC2 instance. Right, so that's it for the intrinsic function demo. Now we go to mappings. So mapping section is another optional top-level section of a CloudFormation template. It is used to define maps, their keys and values, which can then be referenced in your template. And shown here on the right-hand side is a YAML formatted example of a mapping section. And one useful purpose that we will see through our upcoming demo is to give a meaningful option to the template user. So let's just go to our demo now. So continuing again from the previous demo here, we have metadata, we have added metadata and parameters. However, previously, we still provide user to choose between T2 micro, T2 nano. Some user might not know the difference between those two type of instances. So in here, I first will remove the metadata as we no longer need it. And I will add mappings section instead. So this is the logical naming for my map. And again, must be alphanumeric and limited to 255 characters. So I will name my mapping environment to instance type. So now I will try to provide user with a more meaningful name, for example, test or prod. So either you choose you want to deploy a test EC2 instance, or you want to deploy a production EC2 instance. So in here, I will have now a second level key, which is the instance type itself. So when user choose the test environment, then it will map to T2 micro. And now my second key, which is prod, which has the value of T2 dot small. And now since I have this, so I will change this. So instead of asking the instance type parameter, I will actually ask environment type. So let me now type in a new parameter, which is environment type. So this is basically not the instance type anymore, but specify the environment. And I will provide the type, it will be string as well. And the default value, for example, I will specify as test and the allowed values. So instead of providing the instance type directly, the allowed values now will be test or prod, which then will be mapped in the mapping area. And this is the constraint description. So constraint description is a special property here, which it will only show up when user did not actually choose one of them, or user tried to put an empty. Now, since I have changed this, so it means in the my resource section, I need to remove the instance type here in this line, because we no longer have this parameter. So we cannot just reference directly because that's a mapping. So in here, I will use one intrinsic function called find in map, which is to find the value within the mapping. So first I need to specify what is the map name, which is environment to instance type. And then the first key. So this is where I will ref the value selected by the user. So this will be environment type. So either user choose test or prod. And then the second level key, which is the instance type here as defined in my mapping. And also one more place I need to change will be the naming and the tagging. In the last line there, I still have the instance type. So I need to replace this. Now I will change just to environment type. So this is a typo. Let me correct this. This will be environment type. So now our EC2 instance will have a name either task-web server or prod-web server. This will be more meaningful name to the user. So now let's update our latest stack. So same procedure here. To demo here now, let me see, we have two now different value tests or production. I will choose production here. So now again, when I choose the production, previously we have a different like instance type. Now we will choose the T2 small. So again, here we see the review in the summary page. When I update the stack, this will actually create a new EC2 instance. And this page here, it shows all the details here in case you want to debug if there's any failure in your CloudFormation template deployment. This is also where you will see the granular details of the event. Now we click here. Now we can see that the name has been changed to production, prod-web server, and the instance type is T2.small. And again, you can see the status check is initializing, which means that is a new EC2 instance. So I will pause here for a sec and see if there's any question from the audience.
Hey, Mardianto. So there was a question that we're going to talk about in a second. However, I want to call out, so the first portion of the demo, you created a new EC2 instance. Obviously, whenever you create a new anything, it's going to build it from scratch. The second portion of the demo, you talked about updating existing resources. So within CloudFormation or any infrastructure as code for that matter, there's different ways that resources are handled, whether or not it's completely like deleted and redeployed, and there's interruption that's involved with it. Highly recommend reading the documentation to understand what sort of behavior you should expect to see with the different resources and things, because there may be interruption, there may be partial interruption, or the resource could be completely deleted and decommissioned and then deployed as new there. So definitely want to read the documentation for each of the resources to fully understand what the implications are. There was another question there that came in from Dear Felix, and they want to know, are there any plans to improve debugging in CloudFormation? Error messages are still often vague and not helpful.
Yeah, I think that's also a good input. So thank you for that. I do see some kind of some also same things from my customer. So that's something that I don't know the answer right now, but I can check with the CloudFormation product team. And also you can put that actually in your AWS repos, and we'll get back to you there.
Yeah.
Go ahead, Hiran.
Sorry, quickly, thank you for the feedback. I will also share it with the team. But currently there are two ways we can do it. So quickly wanted to share that. One is that you can validate your templates by something called AWS CloudFormation Validate Template, or also Validate Template Operation. It will first check if there are any errors in your JSON or YAML code. And if the checks fail, then it will be a validation error. And something you can do as well is you can create a change set before updating the stacks. So that way you will see the proposed changes of what a stack might look like before you implement them. So those are few ways where you can validate and verify before implementing.
Right. And also I can add to that, we have a tool called TaskCat as well to test your CloudFormation template deployment. And they will actually deploy the CloudFormation stack, but they will you will see all the, for example, if you have multiple deployments, you can use that quickly to just use one template and deploy in different multi-regions.
Great. Thanks for the questions. Keep them going there. We've got a few minutes left. So why don't you wrap it up for us?
Thank you. So the last one, last but not least, is the output section. So the output enables you to get access to information about resource within Stack. For example, you can output the S3 bucket name for your stack to make the bucket easier to find. And furthermore, output values can be imported to other stacks. And these are known as cross-stack references, which is now a more advanced topic not covered today. And the maximum number of outputs in a single template is 200. And shown here is just the YAML format template of the output section. Now let's go quickly to our demo. So previously in our demo, we see in the outputs of this UI console of CloudFormation, there's no output at all. So we will continue from our latest deployment here. From our latest template, we add one more output section. So the idea here, I will try to output the public DNS name for the EC2 instance that I deploy. And this is just the logical ID naming for the output. The same, this is alphanumeric, maximum of 255 characters. And the description, this is the public DNS of the EC2. And in here as well, I will demonstrate we will use one intrinsic function, which is the get attribute, to get the attribute of this public DNS from the EC2 instance. All right. So I will save this and we will redeploy. And it will be rather fairly quickly because I will not change any of the configuration here. And it will just print out in the output section of the CloudFormation UI console. Click next here, and I'll click next. So no changes done here. But right now, after we update this stack, we will see the public DNS of our web server instance will be in the output sections of the CloudFormation console. There you have it. All right. So that's the final of our demo. And so the key takeaways. So infrastructure as a code, actually, just to recap, the benefit of AIC is rapid deployment, there's the infrastructure that you can replicate, redeploy, and repurpose. And you can version control your infrastructure. Since you treat it as a code, then you can check it into version control system, and you can actually review them before actually deploy them. And also, which brings us to the CI/CD pipeline integration. You can integrate and automate the infrastructure deployment with the CI/CD pipeline. And specific to AWS CloudFormation, the deployment automatically rolls back to the latest working states if any failures happen. And as we have seen through our demo today, it is fairly quickly simple to start with AWS CloudFormation to build your infrastructure as code solution. And one last thing, we have more resources here, and on top of the links that we have sent through the chat. And there's a tool to link also the CloudFormation template, and also I mentioned the task cap here. And so here are just some useful links to get started with CloudFormations. And again, if you have any questions, feel free to post it in the repost question where I can get to that, and also AWS subject matter expert can help you also with your questions. So that concludes my demo today.
Fantastic. Sorry, I had got lost in the browser tabs there for a second. My apologies. So we have come up on the end of today's show. Today we were joined by Mardianto and Hiran. Both are AWS Enterprise Support Technical Account Managers. And the focus of today's discussion was getting started with infrastructure as code and two of AWS's native infrastructure as code tools, which is CloudFormation. And then earlier in today's Twitch episode, we talked about the CDK for a few minutes as well. And really the premise of this was getting started and how to start codifying infrastructure so that you can start deploying your own CloudFormation templates within your environment. If you do think of any questions after the fact, please feel free to head over to repost.aws, ask your questions there. One of our experts will be happy to help you. And that's leads me into the next portion is AWS Supports You airs every Monday at 11 a.m. Pacific, 2 p.m. Eastern Standard Time. And we're always looking for new and exciting topics to present and have experts like Mardianto come on and talk about. So oftentimes we'll pull questions that are, popular topics over on Repost. So who knows, maybe one of the questions that you ask over there will wind up being a future episode of AWS Supports You. We are also interested in your feedback. Earlier, I posted a link to a survey. You can also send us an email at awssupportsyou@amazon.com. Let us know what you think of the show. That's your opportunity to have a voice. And like I said, every Monday, 11 a.m. Pacific, 2 p.m. Eastern Standard Time. Next week's episode will be around introducing the Enterprise Support Operations Review with one of our senior specialist TAMs, Chris Pates. So Mardianto, Hiran, thanks so much for joining us today. It was a pleasure having you here.
Yep.
Likewise. Thank you, everyone.
Fantastic. Everyone, thanks for joining us on AWS Supports You, and happy cloud computing.